Learning target is I can identify and describe the transformation of a function from the equation or the graph. So we're going to look at some transformations and how they're affected. So the general function translations, if something is affecting the outside or the entire function, it affects the vertical direction of the graph. If it's something inside, it's going to affect the horizontal. So if it's directly being added or multiplied by the x, that input, it's going to affect the horizontal direction of the graph. So I have the list of the general rules of each of our functions. The first two describe a outside effect. These affect the vertical. So this is when we add or subtract a number on the outside of the function. So we add k or we subtract k. If you add k, you move up however many units k is, and if you are subtracting, you move your function down. If you are moving right or left, okay, you can see here the difference. Now the h's are impacting what's inside the function. They're going to be added or subtracted directly from the x. The key here to note is that what you see is what you get with k, okay? So sine is true. If you're in my class, I like to call K Kelly, and I say that Kelly tells the truth. And H, the sign is the opposite because Hank lies. So notice how my sign here is a negative, but it says to move right, and right is really the positive direction. So same here when I'm adding H to X, I do the opposite, so I'm really moving left or in the negative direction. And then my last two affect the stretch or compression of the graph. They either make it like taller and skinnier, or they pull it out and make it wider if it's being compressed. So if you have a factor out front of the entire function, remember if it's outside that function, it affects the vertical. So this is a vertical stretch or compression. And if I have that value inside with my x, it's going to be a horizontal stretch or compression. So those are the general rules. If you want more specific rules, specifically for quadratic functions and exponential functions, you want to see examples, you can download that graphic organizer in the slideshow presentation. Okay, so we want to determine the transformation. I have my general rule. We're going to do some examples with quadratics this morning rather than exponentials, but the same types of things would apply with exponentials. So in number one, my original function is x squared. My new function is x squared plus 5, and I want to describe my transformation. Well, I noticed that the big difference here from my first function to my new function is we added 5 at the end. And when I add 5 at the end, that's just like adding k. And k tells the truth, Kelly tells the truth. So what it says is what we get. So my change is 5 units up. Okay, the second one, here I have my original function x squared plus 4, and then my new function j of x is now x minus 3 all squared plus 4. So the plus 4 is the same. What's new here is I now have x minus 3 all squared instead of just x squared. So when we have an impact on the actual variable like we do up here, this is when we have that horizontal transformation, and the sign is opposite of what's really happening. So since I have a negative, that really means I'm going to be moving in the positive direction 3 units. So I'm moving right 3 units. Next we have f of x equals 3x squared minus 2, and my new function is h of x equals x squared minus 2/3. This one on first glance is a little bit trickier because we're not just adding or subtracting something here. But what I do notice, I kind of look for those changes. So I started with a 3 and a 2, and then I'm left with a 1 and then a 2/3. So to get from 3 to 1, if we were to have divided this first one by 3 and divided this second term by 3, look at how we end up with where we're at. So 3 divided by 3, that gives me this 1 here. and then 2 divided by 3 gives me this 2/3. So what this means is I essentially took this entire function. I'm going to kind of show you how I would have written it given the translation. And we would have multiplied this entire function by 1/3. Okay, so that's going to be a change vertically because I'm multiplying the whole function by that, and that's a compression factor of 1/3. It's a compression because it's in between 0 and 1 instead of a stretch. Okay, and then lastly, I have f of x equals x minus 1 all squared and then minus 2. And my new function is m of x equals x minus 6 all squared minus 4. So there's a couple things happening here. I'm changing from -1 to -6. Okay, so how do I do that? Looks like if I took -1 and if I subtracted 5 more, I'm going to get to -6. Okay, if I went from -2 to -4, I'm going to subtract 2 more to get to -4. Okay, so you're just trying to figure out, okay, what did we have to add or subtract or multiply to get from my original function to that new function? So here for my k, the number on the outside, okay, we moved down 2. I subtracted 2. Okay, now I subtracted 5 in the x direction, but remember that's opposite, so I'm really moving right 5 units. All right, so there's some examples of giving the original function and the new function. We're describing that transformation. Another example, this is a little bit different. If you want to try this one on your own, you can, but it is slightly different than what we just did because now we're given the visual. So this says the graph shows g of x, which is a translation of f of x equals x squared, and we want to write the function rule for g of x. Now I know my parent function here, f of x, that its vertex where it starts is always going to be at 0, 0. Okay, so it would open up something like this. Okay, that's what the parent function of x squared is always going to start with. Okay, it hasn't been translated at all. So the big difference here I notice is that this function has been shifted down 8 units. It's like they picked up the original function and they just moved it down here so that the vertex started at -8 on the y-axis. So when that happens, that affects my k value. That's that vertical shift up or down. And since I'm going down, that means I'm going to want to subtract k. So my new function is going to look like this, x squared minus 8. I'm starting with my original function. We're just shifting it down 8 units, so we subtract 8. If you need some more information on this topic, you can check out the Learning Target spreadsheet for additional resources, videos, and practice.